So thank you again for joining us. As I mentioned, the COMET community is a diverse group represented by many of the people in this room. And we all share and value metadata that is quality and metadata that is complete. And that's essentially why we've come together today and in our work. We are here to make metadata richer together. And our primary goal is improving the quality, completeness, and interoperability of scholarly metadata. In practice, this means that we need to evolve metadata enrichment into an open, shared, and evidence-based practice. And this social aspect requires technical coordination so that our systems can speak better to each other, so that we can flow this metadata, these improvements, into the systems that maintain and disseminate scholarly metadata. And we're aiming to do this at scale. We come together with a deliberate goal of collaborating because the current workflows for maintaining and improving the scholarly record are disconnected and insufficient. And I'm sure we're all familiar with at least some of the reasons for why that is. Metadata production is part of many broader workflows, and it's characterized by complexity, by non-transparency, duplicative work, and resource-intensive work. Metadata is created in many different systems with different schemas. Those schemas have multiple versions. It's often done in a way that is undocumented and in systems that are proprietary, which naturally stops us as the community, from interrogating how that metadata was created. This all leads to duplicative work. Separate individuals in different institutions are working on improvements in their own systems, and these are really shared between our systems. So this work can be very resource intensive, not only in this high curation effort, but in high infrastructure costs. And these costs and effort could be shared if we were working more cleverly together. Just one example of how the current model produces this type of isolated benefit. This diagram over here is showing you the DOI process where an individual creates a DOI record. It's consumed by various services who need and can improve that record, but that value then ends up being siloed and separate from each other. So this is why we've come together, and you can find out more about COMET's story on our website. But briefly, it started in late 2024 when there was early momentum seeded at conferences like Force 11. And then we came together as a dedicated group and formed a task force to focus on designing collaborative metadata enrichment and how it should function. We then organized with different community partners and came up with some pilot projects to validate different approaches to metadata enrichment. And now, as those results and lessons are starting to flow in from the projects, we are focused on building community capacity and the infrastructure to take this work forward. And so our kind of organizing theory around this is the COMET model, which helps us put a new framework in place. And we're learning as we go along, and these lessons are based from other good examples of community work around us. At its basis, the COMET model is a technical and social coordination framework for community metadata enrichment. You can find out more on our website, but in summary, it has three foundational principles. The first is that the stewardship of metadata or metadata's quality should be a collective act, and we need to shift this responsibility from individual depositors to a distributed community partnership. The work that we do together can create collective benefits, which is the opposite of what happens currently when organizations tackle metadata problems in isolation. It results in fragmented benefits. So if we work together, we can all enjoy the same benefits. And finally, Sorry, my screen is not working. Finally, that we can root trust in transparency. And at the moment, we have an individual or the person who created a record, their identity is a very important trust indicator. But we can expand this trust to include open and rigorous processes as an indicator of trust, which becomes particularly important when we start talking about creating metadata together as a collective. I'm going to zoom back and just show very high level what we have managed to achieve together so far. We've created reusable metadata enrichment assets. So we have these enrichment methods, we have evaluation benchmarks, and we have documentation. All of these assets are coming out of our work together on the pilot projects and new community partner projects that we're starting to implement together. You can find out more about those in context on our website. All of these are serving the goal of building community capacity. Then, of course, we have the enriched data sets themselves, some of which represent completely new connections in the scholarly record. And along with these data sets, we are creating provenance records that show who created the metadata and how it was created. All of this being linking to openly documented resources. So these two things, the enriched metadata and its provenance record, can travel together into our systems. And we also have the first demonstrated example of this, where we are round-tripping enrichments to DataCite's new enrichment layer that is now in production. This is the first pathway that we have created together, but it's one of many different pathways. But importantly, these first pathways are something that we need to prioritize, because when we put metadata into, when we put improvements into open metadata, then it speaks to our goal of creating a collective benefit, and it counteracts the current situation where values are being fragmented across the system. So this is a first version that's in production. You can read more about it on DataCite's website. We really want to get more feedback, so use it, try it out, and send your feedback to DataCite. I hope that provides sufficient context for what's to come. And now I'm going to hand over to Adam and Path. Thanks.
Thanks so much, Dione. Hi, everyone. My name is Adam Buttrick. I'm a product manager at the California Digital Library, and I'm here today with my colleagues to talk about all of the exciting work we've been doing to unlock new funding metadata. Specifically, I want to walk everyone through how we built an open, scalable, and cost-effective pipeline that allows anyone to extract funding metadata from the full text of works. Can we pull up the next slide, please? So before diving in, let me just start briefly with why we took on this project around funding metadata. So at a high level of all the things that can be associated with research output, obviously it's among the most high value. So funding metadata is what lets us connect grants to the works they produce, lets funders see their return on investment. It gives institutions the ability to understand and adjust how resources are being allocated to all the important problems they're working on. It underwrites faith in public investment and supports all kinds of research integrity goals more broadly. Closer to home for me, the need for high quality funding metadata is something our teams here at the University of California Office of the President, where the California Digital Library is based, kind of grapple with on a daily basis. So for context, we have a research grants program office that oversees a really broad portfolio of high impact funding programs, providing over $100 million a year in grants for critical domains like breast cancer and HIV/AIDS research. So I work with this team on things like grant DOI registration and funded works discovery. So I really see firsthand the impact that incomplete funding metadata has on this work, how it really impedes and frustrates critical needs and analysis. Can you pull up the next slide, please? So to index a bit more on those gaps, we should acknowledge that funding metadata does already get produced by various means. So publishers collect and assert it, directly from authors, mine it from funding statements, or rely on production vendors to do either of those things on their behalf. Data repositories similarly capture funding information at deposit, typically from depositors' supplied fields or researchers. At the same time, we also know that the gaps in funding metadata are quite extensive. So some publishers and repositories don't provide funding metadata at all. Others lack kind of sufficient QA. And in many cases, this information is simply lost along the way, whether in the process from submission to publication or between data being deposited and the metadata that ultimately gets exposed downstream in sources like DOIs. Next slide, please. So to provide a concrete example, research by Hans de Jong from the Dutch Research Council, or NWO, and Bianca Kramer, I think at that time at Utrecht University, now at Sesame Open Science and Barcelona Declaration, examined a set of publications that grantees had reported as funded by NWO. And so these are publications which should therefore carry corresponding funding metadata assertions. They found that only about 67% of these publications had funding metadata present in Crossref, that 53% identified NWO by name, and that only 45% correctly identified NWO by its funder identifier. This was true even though an additional manual spot check of two of the publishers found that most of the papers missing Crossref funding metadata did carry that information in the form of their acknowledgements. So that's just one example of the quite sizable gaps that we can know exist empirically, where we can measure against a known baseline. For all other funders, for many other venues, we really have no way to assess without repeating this complex, detailed form of analysis. Next slide, please. So if we really want to change the story around funding metadata, as with other of our work on COMET, where we have to start is by building data sets and evals that capture empirically all the aspects of what it means to close these gaps. Here, of course, meaning to completely and accurately derive the funding metadata present in the full text. So to start talking about this in more detail, I'm going to hand things over to my brilliant colleague, Parth.
Thanks, Adam. Yeah, I'm Parth. I am a researcher in the School of Education at Stanford and an organizer of the COMET project. So I want to talk a little bit more in detail about some of the specific computational methods that we use to derive funding data from the full text. So the rough picture here is that we're starting with a copy of the full text, usually as a PDF, and we're trying to produce assertions about funding metadata. So we started for this particular project, we started by building a data set of inputs from a random sample of all of the preprints in OpenAlex, with the thinking here being that journal articles start as preprints, but often have more copy editing and structured formatting. So a model that can handle the messy structure of preprints can hopefully generalize a little bit better. And we converted these preprints to text, so to a format called Markdown, for those who are familiar with that, but you can think of it just as a text file, using two different methods. One is a sort of high fidelity method that in this case uses a vision language model, and also a lower quality method that can be run much, much faster, something that we could use at scale for a very, very large document corpus. And in this case, we used a library called PyMu-PDF. And it produces text that's less well structured, but but faster and cheaper. And so the thinking here is that by producing both representations, we can ensure that both that our model is robust to both kinds of representations, but also that we can measure how the conversion process affects the quality and the overall performance across our set of extraction and metadata and parsing tasks. Could we look at the next slide, please? So this overall task of making assertions about funding metadata was, for this project, we split it up into two different pieces. The first one we call extraction, and the second one we call parsing. And we split it up into these two subparts, mostly for technical reasons. That is, that this is how we actually trained the models, and this is how we evaluated the models. So the first task of extraction is about identifying the funding statement inside of the text, if it exists, or accurately saying that it doesn't exist exist if it doesn't exist in the funding in the article. And the second part of it is to take this funding statement and turn it into structured metadata. So specifically, we're looking for the funders, the award IDs, the funding programs and schemes, and the award titles. So it's those sort of four different components of the of each of the funding statement. So to evaluate both of these two tasks, we created dedicated training and benchmark data sets where we paired each full text with its funding statement. So that part allows us to evaluate extraction. And then we took the funding statements and we hand annotated all of the different funding entities, those four different funding entities I mentioned earlier. And that allows us to evaluate parsing. Next slide, please. Okay, so then we started thinking about how to build or evaluate existing models for these tasks, and we started researching all of the different approaches, the training methods, the models, and this was a very complicated process. For some of you who saw our earlier the last talk we gave about affiliation metadata, this one was substantially more complicated and tricky. And I don't have time to get into all of the different variations that we went through, but I will just cover some of the highlights for the things that we learned and the overall takeaways of the process. So for parsing, the primary takeaway was that the initial data set that we put together was too small and not diverse enough to successfully train models. And could you, next slide, please? So to fix that, we tried something that I think is becoming increasingly common in the machine learning and AI literature, but but can seem a little bit counterintuitive. So I think perhaps the most obvious thing to do if your data set is not sufficiently diverse is to go and get more data, to sample more data from OpenAlex, to go and do another round of annotation. And that I think probably would have worked, or it might have worked if we were able to sort of tune all the knobs correctly. But instead of adding new data, what we did is we tried to figure out what our models were struggling with and actually generated synthetic data. So data that does not exist at all in the real world, but generate synthetic data and train on synthetic data um, to sort of fix those areas or fix that behavior in our model. So you can see on this page what those synthetic statements look like. We basically generated the synthetic statements in the placeholder format that you see at the top, and then we filled in real funding names and award ID pairs that we got from Crossref into the funding statement, and then that gave us a kind of fuller, like a more complete funding statement, which we were then able to reliably match with this synthetic gold annotation, and then we could train the model to reproduce this. Next slide, please. So we also needed to make sure that our models for both of these tasks were robust against real-world conditions where the funding statement text can be degraded in various ways or contain extraneous text at the beginning and the end. And so for both the manually generated and also the synthetic data sets, we added these synthetic edges around each statement, mimicking what might actually appear before or after a funding statement. Next slide. We also added some synthetic noise. So we went and looked at what kinds of degradation appears during the process in which the PDF is turned into a text file. And we actually explicitly added some of these things back in. In this case, this was hyphenation breaks, lost spaces, residual XML markup, and so on. So again, in all of these cases, the aim is to train models that can handle the messier real-world text that they actually encounter. Next slide. Okay, so now let's get into how the pipeline for extracting and parsing funding metadata was actually trained. So we have this kind of improved data mix in hand. It is sufficiently diverse. It contains the appropriate kinds of noise. And with this improved data mix, we were able to develop a custom parsing and extraction pipeline that first finds the funding statement, that's the extraction step, and then it parses it into those structured formats. So I'm going to break down just extraction, and then Adam is going to talk about parsing. So for extraction, there's actually 3 different stages to this extraction procedure. So the first thing that we do is we take the document and we break it up into different little chunks. This is 8,000 token chunks. And we pass these through a very lightweight BERT classifier that scores each of these little chunks to say how likely is it that a funding statement actually occurs in this chunk or not. So we immediately narrow down the very long paper into the most promising chunks, which score highly. That's this stage 1 box at the top left. Okay, so then we go into stage 2, and again, using a BERT model, but a different BERT model this time, we produce not a score for the overall chunk, but a score for each of the each of the tokens inside of that chunk. So we read those chunks and pull out the specific character span that corresponds to the funding statement. So you can see we're kind of narrowing in on the funding statement here. And then finally, and optionally, we use stage 3, which is a much more heavyweight model, which takes the span from the document and can rewrite it into a cleaner version of the statement, which corrects for text degradation that might have occurred for the PDF conversion. So this last model, the idea here is that we could produce a sort of a polished version of the funding statement that might actually be the type of thing that you want to enter into the metadata record. But also this last model was actually trained in tandem with the parsing component of the COMET pipeline. So the idea here is that this last model produces these funding statements, which are especially well prepared to go into future steps of the COMET pipeline and guarantee you higher accuracy down the road. So the point of using these 3 models is that this heavy lifting, processing the entire document, can be handled by these very fast, inefficient, and inexpensive models that can run on CPUs rather than on GPUs, at least for the first 2, the modern BERT models. And the next step, the parsing step, it's, as Adam is going to cover, it's going to be much more computationally expensive. And so the point is that this first step of finding the funding statements can be done using much more computationally efficiently. And then the more expensive step just has to process a very small part of the document, just the funding statement instead of the whole paper. We actually did some testing of the parsing step either on just the funding statement or the whole document and found, of course, that processing the whole document is more expensive, but also it performs worse. And so this as being an initial step is really important to making the whole pipeline work well. The last thing I want to say is that the cascade method recovers the funding statement with an F1 score of just over 0.5 using a lenient form of matching, so pretty good performance overall. And I will turn it back over to my lovely colleague Adam to talk about the parsing step.
Thank you so much, Parth. So the next stage is where we want to parse structured funding metadata from a funding statement. Specifically a JSON object listing each funder with its award identifiers, funding scheme, and award title. So here what we do is we fine-tune a small open-weight large language model in 2 stages on our dataset mix. So the first stage, which we diagram here, is just straightforward supervised fine-tuning, where we show the model thousands of funding statements, each paired with the correct structured funding metadata JSON, so it learns to map from one to the other from funding statement to that JSON. Next slide, please. We follow this training with a round of reinforcement learning using group relative policy optimization, GRPO. So in GRPO, instead of training against a fixed target, what we do is have the model generate several of its own attempts for each prompt. So again, trying to parse the funding statement to the structured JSON, with each attempt then scored against the gold dataset annotations. It then uses the group's own average score as the baseline. So attempts above it are reinforced in the model, and those below it are discouraged, weighted by how far each deviates from that average. Next slide, please. So for this reinforcement learning step, we have to have a form of evaluation for each of those rollouts. So we do this against the gold data set, where we use a reward function that gives the most weight to correctly parsing the funder, matching on the funder name with a bit of fuzziness. We then also reward parsing of award identifiers, but hierarchically. So an award ID earns the most credit when nested under the correct funder, because that's what we want. We want to find the funder paired with their award ID. But we also then layer in some partial credit for award IDs that are parsed correctly but attached to the wrong funder. Both because just in training, we found that this produces a more precise outcome overall, but it also gives the model additional signal to learn from across many rollouts. Next slide. Okay, but then in terms of how it all performs with this approach, the training on our held out benchmark, the funding entity parsing extracts funders at about 94% precision and 94% recall using our permissive form of this eval. Award of identifiers coming in around 91% precision and 90% recall. So in our testing, this matches what large open source and closed model performance can do. It's before the release of Fable and the new GPT models, but still very good performance overall. So great result. Next slide, please. Um, but so now that we had a working pipeline, what we also wanted to do was test it at scale to get a kind of real sense of orchestration complexity, cost, and the practical realities of running it kind of end to end. So a good target for this had presented itself over the course of the project. So in conversations with Hans de Jong from the Dutch Research Council, whose research I highlighted at the start, we learned that they had this kind of dire need for funding metadata from arXiv because they run a physics funding program. And then arXiv, kind of being the premier venue for this field, simply doesn't have this metadata available. So Hans and his folks who are doing kind of business intelligence around this couldn't derive. arXiv, for their part, had also indicated a need for the same metadata. So then working with arXiv again made for an ideal test case, it being both a large real-world corpus and one where the metadata was absent, and we knew that our results would therefore be immediately useful to people who needed them. Next slide, please. So we ran our pipeline across the full arXiv corpus using commodity GPUs available via the Hugging Face platform. In this case, A100s, which are at this point about 6-year-old GPUs that, depending on the workload, are anywhere from 2 to 9 times slower than kind of modern cards that are used for large language model training like H100s. But it's so in under a day and for less than $1,000, we were able to run the full end-to-end pipeline across 3 million works in arXiv. Successfully parsing funding metadata from about 1.8 million of them. We then match these outputs to varieties using Crossref's great new funder matching strategy. The result is a large open data set of structured funding metadata for arXiv that anyone can now download, inspect, and build upon to kind of understand the funding that is occurring there. But as always, for those who aren't too keen to wrangle large data files, we also put together some demos that show this work. So I'm going to attempt to share, and then we'll walk through these. Okay, let's see. Okay. Are we seeing my screen? Okay. So this is just one example of an arXiv work that I found when I was reviewing the results from running the whole pipeline. I like this example because what we have here is a mathematics paper from 1999. And if we start scrolling through the text, what we find is that the funding occurs right here in the middle of the second page, kind of nested between a set of equations. It's not at the end. It's not in the footnote. It's not in any of the places that you would expect it. So, the model has to go through, as Parth was describing, chunk all of the document and trying to find a specific text. So we mocked up a little just web application to demo. So this is actually even slower than it actually performs because we have all of the overhead of doing HTTP stuff and everything. But so we can just feed it this link to this arXiv work. What's going to happen behind the scenes is it's going to convert that document to a text format using that PyMu PDF library. So then it's a very messy text input. And then it's going to try and isolate the funding statement. So okay. So we can see the actual inference actually took only 0.8 seconds. I'm trying to save money, so I make the computer shut off every time it's not running this. But we actually correctly isolated not only just the funding statement, but within the acknowledgement sections, the specific sentence that mentions funding. So there's actually this extraneous text that precedes it that's just acknowledging collaborators. And this is the part that identifies the funding. So very precise. Okay, so that's finding the statement, which the models do very well. The next thing we have to do is, again, parse the funding statement into structured metadata. So here I have an example statement that we've similarly kind of degraded and corrupted. So it's all kinds of messy. You can see we have just random trailing backslashes, and we like replace some letters and join together funder names. There's all kinds of extraneous tags, commas, line breaks. So what we can do is we can take this, And oh, sorry, I already copied it over here. Let's make sure that it is. And we can feed this into our funding entity parsing model to run inference. So this is the model, the same model that we used for parsing all of the works from archive. And we can hopefully see that it's able to correctly recover all of the funders and award IDs in a properly structured format. So we see, even though it was corrupted, model doesn't care. The model's been trained to correct for that kind of corruption. And then using the cross-draft funder matching strategy, we can also link them to their correct corresponding award IDs, associate the correct award identifiers, and then even in some cases, grab the funding schemes. So pretty great result. So what we did again was to take all of the works in archive and run them through this two-stage funding extraction pipeline. So now we have an account of all funding that has occurred in our archive. So this is just kind of an aggregate view of the top funders in archive. So we can see things that we might expect, like the NSF in the US being a top funder, various European Union, Department of Energy, prominent funders from Japan. We can also now do analytics about specific funders. So if we pull up the Dutch Research Council, who I've talked about a lot in this session, we can see their details. So from the account the model produced, they've funded at least 21,000 works. We can see the growth in funded works over time, probably corresponding to the launch of that physics funding program, among others. We can see who their top co-funders are. So obviously we see a kind of a lot of expected names like European Union funders, but we can also look at it because we've mapped these to ROR IDs. We can also see at the national level who their top collaborators are. So for example, I'm in Tokyo right now. The top collaborating funder in Japan is the Japan Society for Promotion of Science. Okay, and then we can also actually dive in and see the works that they've co-funded specifically. So this is just a list of the 400 works that were co-funded by NWO and JSPS. And we can repeat this form of analysis for any funders. Okay, so I'm going to stop sharing. It's the demo portion. Go back to our slides.
Are you done, Adam?
I am. Yeah, can you pull them back up?
Sure, yeah. I'm going to share my slides now. Okay, thank you, Adam and Path, for taking us through all of that.
Oh, so I have a few more takeaways.
Okay.
Sorry, Diony.
Go for it.
Yep. So just kind of to bring things back around, with this pipeline, we can now produce high quality structured funding metadata at scale using open models the community can afford to run. And just as importantly, in a way where the quality is measurable and the whole process is open to refinement. So now we can empirically know how well we can extract funding metadata from full text. Next slide, please. Looking ahead, we actually already have quite a bit in motion around this work. So as Diony mentioned at the outset, we're collaborating with DataCite to fold this data into their new community enrichment layer, which was also discussed in more detail in our last meeting. So check out that recording. That way, the funding metadata that we are producing can flow back out to everyone who's harvesting from that source. We've also been working with the funders who lead the Barcelona Declaration funding metadata working group to review the archive results in more detail and explore how we might use their kind of internal accounts of things like funding schemes and programs to further refine our processing pipeline and identify new funded works. Next slide, please. Additionally, we're looking at extending our training and benchmarks to additional languages and contexts. So for example, this corpus was all English language training. We want to be able to adapt to other languages and contexts. Exploring some new large-scale parsing opportunities with additional partners who hold full-text corpora, and seeing how we might fold the specific funding entity parsing model that I demonstrated into the ROR API, such that anyone can then use it to extract and match funding data from funding statements. So if any of that resonates with you, we'd generally love to hear from you. Please don't hesitate to reach out to us. I think that's all from me. As always, everything from this project, code, data sets, models, it's open source, it's on GitHub, it's on our Hugging Face accounts. So if you want to use it, you want to extend it, you want to build new things on top of it, we love all of that. All from me, turn things over to Diony for a discussion session.
Great. Thank you, Adam, and thank you, Path. for taking us through the detail. Just want to remind everyone that everything we've discussed today is also available in documentation from our website, and we'll also be publishing a version of these results in a written record, and we'll let you know once that is available. But we do have a good 20 minutes left, which is great for our discussion. I'm going to open up the mics now. One moment. So we do have some topics on mind, but we can also start with conversations and questions that have come up in the chat. So let me unmute everyone and feel free to speak. One moment.
Yeah, so I can address one question that Toby raised just at the start, which is that a lot of the work that we've been doing has been focused on article or article-like resources. So in this case, preprints and journal articles. But there can be funding metadata and other text sources. So Toby does a lot of work with books, reports, all of those kind of things. As I was saying, we're looking how we can now extend this kind of working training method to other contexts. So that would involve building training corpuses that include some of those other document formats, doing similar annotations, as well as just some general benchmarking to see how the existing things that we've trained kind of work just off the shelf. There's another question from Thomas about, have we tested it on non-English documents? No, not yet, although we're planning to do some work around non-English documents relative to all of our collaborations with PKP. The challenge is actually deriving a sufficient corpus for either a set of dominant languages that kind of reflect a distribution in a set of published research outputs, or which kind of capture everything that could be possible. The models themselves tend to be trained on a certain language mix, and so might not always generalize well to, for example, languages that are not well represented in their corpuses. But we know that we have some opportunities to collaborate, for example, with folks in France, and look if we can extend some of these training methods and annotation approaches and construction of benchmark data sets to a French language context. We think that the overall approach should generalize well to any case where the model essentially has that language kind of sufficiently represented in its underlying training corpus.
I'm going to stop sharing my screen so we can see each other. And if you want to turn on your camera, that would be great, but no pressure. But I wanted to say that the mics are open. It would be great if you did put a question in the chat. Let's discuss that by raising it yourself. Otherwise, we did have some topics that we would love to get your input on. Has anyone got a question? We can't open cameras. Okay, thank you for letting me know. I will try and fix that now. Start video. Okay, there we go. Great.
There we go. That's better.
Okay.
We see each other
Much
enough.
better.
It's good to see.
Thank you. Anyone want to kick it off?
To go. So first, this is really exciting, really cool. Love, like, followed all of the great presentation, just like really good fun. I'm from OEWorks. One of the tools we've built is OE Report, and that does a lot of work to help funders assess compliance with open access policies. And one of the things we do about that, job number one, is find a bunch of their articles and wrestle with the lack of funding metadata out there and other metadata. And so one of the things that we've done to do that, one of the things we've been really focused on recently is preprints. And like one of the big endeavors that we've been going through there is to extract like tens of thousands of preprint funding statements manually, and in a clean way, and then pass those or search those for the funders in question. And I think probably what we've gotten to is a place where like we've got some pretty comprehensive data for preprints for a few different funders. this isn't meant to scale in the way that all of your work is meant to scale. But it is meant to maybe provide good raw data for this sort of
Yeah,
for this sort of process.
yeah, absolutely.
And help like that kind of that scale like that kind of scale up process. So I mean, one of the things I like look at this is I was like poking around a bit before, and I was like, is there an API I can just hit and like have some fun, like see if there's anything that we can see how it compares, or see what we can feed in and kind of get out. And maybe I just missed that, which is totally my bad, or maybe it doesn't exist yet, in which case, like, is there anything we could do to like help fund standing that up, or just kind of like, is there anything we can do to kind of like, rather than running all of this ourselves, just kind of let people have a play, and like, can we support that at all?
Yeah, so we do have actually example code for running the model for parsing and unfunding statements. So it's pretty easy to set up on something like a Hugging Face
Yeah.
or a similar GPU inference platform if you're a little bit technical.
Yeah.
It's honestly very straightforward to do that at this point, and because the model is quite small, you can do
Yeah.
that. We're also happy, obviously, Joe, to like we can do some of that for you if you want to give us a funding statement corpus to kind of produce that data, and we can give you what the model outputs for it. It is very easy for us to spin it up and run it. Um, we, I mentioned, I kind of touched on it briefly in my takeaways. We would like to put something like this in the Roar API to allow folks to feed in a funding statement and then extract the structured funding metadata, ideally matched to Roar IDs. The challenge there is that keeping the models idle and kind of throttling usage is a lot more complex than, say, like something like an Elasticsearch, index or something like that. So then we have to make sure that if we're going to do something like that, that we have, number one, we can stand it up in a stable and efficient way, that we can cost it correctly, and like that it's a resource and that we probably have to manage access to in some way other than how we are doing that, because the Roar API is kind of completely unrestrained, and except for like very basic rate limits. So those are just all kind of questions and problems that we have to work out now that we've built some of this. But that doesn't prevent us from doing some of the comparative analysis that you want to do, from folks from playing with it themselves. And then also figuring out how to build more in these directions that you're talking about. Bianca, I saw that you raised your hand.
On that, I was just thinking, not speaking from the Barcelona Declaration, but more speaking from data provision and analytics and the Orion collective of databases. It might also be an idea for us actually to try and see if we can ingest your sample data set, also the COSAF funding matching data sets into the Orion collective. So it's then available also for others to do analysis on that, combine it with other data sets using SQL. So you've just given me this idea, and
Yeah.
that might
Yes.
be a way for others to also interact with these data.
Yeah, absolutely. Yeah, that would be great.
Yeah.
So we really just we wrapped up this work kind of beginning mid-June. And so we're really just starting to think through next steps with some partners. So we're really open to anyone who wants to start picking up and running with this in any ways that we think would be useful to the community. And we're happy to help support that work however we can. Juan.
Just want to react a little bit to what Joe's saying. So good to see you here, Joe, in this space, and that you're fully engaged with this. And just to say, like, this, I know that the way that OA works, and disclaimer here that I'm on the board of OA works, and so I know a little bit about what goes on. The ability to create like that kind of, you have the ability to scale up kind of the creation of those of like kind of gold standard data sets, right? Like the pipeline that you have for being able to do that kind of sort of manual work, but still at a sufficient scale, is a great input. And that's the kind of thing that actually can feed the training of these models. So it's like the kind of thing that we think that COMET is here to try to help to address, that kind of coordination, where that kind of work we know happens. I know it works at doing it, but it currently, like, where would you send it? Who would you give it to? Other, how would you?
Right.
And that's why we think that there needs to be, this is part of the problem that we're trying to solve, is that this work happens. It can be super useful for someone else that's doing model training, and that we need to make sure that there is like that connective tissue that's there. And part of the function we're trying to play is to do that, exactly that kind of thing, because gold standard data sets are hard to come by. And the mechanisms and ability to create them in varied ways for different parts of the problems are all key to having this kind of large scale work actually function.
Yeah, if I
Yeah,
wanted to offer a reflection on this too, which is that very often Joe, I'm not 100% sure if are the data sets that you're producing, it sounds like you're finding the funding statements using some automated procedure, right? Or
So
no,
you've
they're all
got,
manually annotated,
yeah.
right?
Oh,
Yeah.
wow.
So the extraction of the funding statements, we take like things that look primarily like funding statements, things that look like acknowledgement statements, and things that look like disclosures or conflicts of interest that like sometimes look to computers like funding statements. Extract all of those by hand, and then our parsing on top of that is because we've then done that very good like early pass. After that, at the moment we're just searching them, but we're going to move to like an LLM like driven model to do a little bit more of this type of thing. But I'm also like, okay, well, what if we can just use your extraction model once we've done that first piece? And if we can not do that, then like, great. There's some other stuff we might do with the. Anyway, yeah. So sorry.
Yeah, one of the things we often do at Comet when we're starting to enter a domain where we don't already have like super reliable, models that work well on it is to train on other model generated outputs. Sometimes people call these silver labels instead of gold labels. And this is a really good way to sort of begin to warm up your training procedures. So something like this, and also to train on the outputs of the Comet models if you want to then go and specialize to a sort of further domain area. These are all very much the types of things that I think make a lot of sense, and that Comet is sort of well positioned to coordinate as like a place that can bring together lots of different training data. Yeah.
Yeah. So for example, Joe, your data sets also would have been very useful in that statement extraction phase where we have the full text and then we know, oh, here's this huge corpus of manually annotated statements that we can then identify as being funding. So we could go and do some further training using that as an additional input. Howard, you've had your hand raised.
Yeah. Well, first of all, Parth and Adam, congratulations. This is a real step forward. I've been following what Comet's been doing since the beginning. And so it's great to see something actually land, right? So this is really exciting. Obviously this has got heavy overlaps with what we do at Chorus regarding collecting funding information. So I would love to work with you folks on, how we can integrate this into Chorus. You could take Chorus data, which is also open, and, start to really make it happen and ultimately feed this all back through ROAR. I do have a question specifically about, is Archive now going to take the metadata that you've now created and put it into their metadata? Something I've been asking them to do for almost 10 years.
Yeah, so we are going to feed all of this metadata into the datasite enrichment layer. So Archive will not directly assert it because they're doing a lot of things right now relative to their transition of being an independent nonprofit. But the new datasite enrichment layer gives us the opportunity to not kind of wait for them to do a full assessment or to adopt new practices around funding metadata, but to assert a source that we know empirically to be high quality and layer it on top in a completely additive fashion on top of their work. So then anyone like Chorus can harvest from Archive and get those assertions from the Archive works, just as if they were asserted by Archive in the datasite DOI metadata. And then also, as that data gets refined and changed over time, can similarly kind of update that ingest. So yeah, we are talking to Archive. We're working with them directly. We're also, as I kind of mentioned, working with a lot of the funders that are kind of implicated in Archive. So in the Barcelona Declaration, this means the Dutch Research Council, the National Research Agency in France, the Austrian Science Foundation, all of which have quite large representation in Archive when you do analysis of the funded works. Our Research Grant Program Office also has a smaller share, but a not insignificant kind of amount of works that are identified. So we want to use that also to kind of refine the process and make it more precise, such that we can expose new funded works and we can make sure that the assertions that the model are producing are correct so they can be consumed in that enrichment layer.
And in the enrichment layer of data site, which I've only cursorily looked at, the provenance of that assertion is made?
Yes, the provenance of the assertion is specifically says that it was produced by Comet. It links to specific details of the model and the data set that were used to produce. Yeah.
Great. That's great. Nice.
Okay, just checking in on the chat.
Yeah, I wanted to offer some thoughts on Xian Young's questions in the chat. Also, my apologies for pronouncing your name wrong. So you asked, I think, some questions about publishers. So yes, I think Bianca made this point that publishers are absolutely one beneficiary of this information, but not necessarily the only one. I mean, this is useful for, researchers who are doing meta-scientific stuff to try and figure out who's funding different articles. It's useful for funders to track the impact of their research. But it's also, yes, to sort of like the demo that Adam showed, like that type of a report, an interactive report could be made using the outputs of these models. And then you asked if this runs in one publication platform or it can be run on multiple publishing platforms simultaneously. I think this is also a little related to Joe's question about whether there's an API for this or not. Currently, we post these models as open source models on Hugging Face. Some parts of it can be run on a CPU, so even probably on a laptop. Other parts of it need some more specialized hardware, but that is easily rentable. And people who have like some sort of basic technical skills can probably put those together, but not necessarily, like there's not currently a publishing platform that is using these and deploying them on their own hardware. I hope that answered your
Yes,
questions.
I just want to give a little more background. So, yeah, you pronounce my name perfectly. That's good. Panyoung Kim. I'm a data librarian at WashU Medicine Becker Medical Library. So I'm a data management sharing consultant, also data curator for our institutional data repository, Digital Commons Data Becker, which is the same platform of Mendeley data. So I'm interested in PIDs and metadata quality and fair data principles, etc. So when I actually signed up for this one, I thought, oh, maybe they're going to try to improve the metadata quality of the published data set to make it more fair. And it was, this is great. Enhancing funding, metadata is super important. And the first group that jumped into my mind was our impact service group. Our data librarians provide impact report to core facility or any PI or department, whatever. So this will be hugely useful for them. And I would love to connect them to Adam or whoever is available to kind of walk them through and how they can use it to pull their report, for example. That's why I was interested, because they generated really thorough report when they do the impact report. And funders we also find this very useful. They want to see where their money is going, and if they can pull the report, it's awesome. So I really applaud on your effort, and I can see many uses, applications of this one. I just wasn't clear because I was typing and listening, so I didn't get to every details about how you apply this model, what is the source, and who can use it, all that stuff. That's why I start typing out. And then because I look at NIH report all the time, and I help PIs on annual report RPPR, so I'm very familiar with that. So if it comes to NIH, yeah, NIH reporter is a golden standard. You get all the information you need, but it's only one funder. And I was very impressed how you can quickly assemble all different funders. That's just impressive. So if you can get that, I just wasn't sure what the source material is is it like a one publisher, the multiple publishers, or are you getting a Google Scholar? That's the question I had. So I would love to connect with you, get more details. I would love to connect you with our impact report team who is doing all the reports, and maybe they can use your API and then, make even more awesome reports. Thank you.
Yeah, we hope so.
Oh,
Yeah,
one
we've
other
been
thing.
working. Sure, go
Oh,
ahead.
yeah, go ahead. I just, before I forget. So the one other thing, I know this, you guys are focusing on in the pits. ROI is a big one, funder ID is a big one, but as a DMS consultant, of course, I'm interested in more metadata quality of individual data set. Is there any? It's far down the road, But I was involved in this RDA, the Tiger Grant funded project called DV4IDA, data visitation. So we actually I tested a tool called Fairlist. So what it does is actually, for sensitive data, restricted access data, it's hard to access. But you can use the data visitation technology to kind of visit the data and then check the metadata quality and then improve it. So there's a QC tool. So I was just thinking something like that, and then if it's already published, unless you have edit access, you cannot directly edit the metadata. But if you can actually input the metadata somewhere else, actually create a separate record, like a zero record, for example, and then connect it to the published data set using the related link or something, that will enhance metadata quality. So it's all about how rich metadata you have so others can understand, interpret, and reuse it. That's what FAIR principle is all about, reusability. Rigor and reproducibility is a separate thing. You deal with it through, method, more ProjectL or something like that. So anyway, so in the future, maybe something like that you could tackle on as you work on this big level stuff first.
Yeah, no, absolutely. So we've talked about data set a lot, obviously, in the context of this project. So we're doing a lot of projects in collaboration with DataCite to improve the quality of metadata for data sets. What form that will take is many directions at this point. So I think that this is a kind of a good way to inform that work and start thinking more in that direction. As you were talking about, there are also existing community efforts that can be pulled into their enrichment layer, separate from anything that COMET is doing. So if groups like the one you were describing are producing enriched metadata for data sets, those can now be harvested and incorporated as assertions parallel to the DOI metadata. So I think that's really great. We are at time. So I think in the interest of kind of respecting everyone's schedules, I'm going to turn things back over to Dione to close us out.
Yeah, unfortunately, we are out of time. There is a lot more that we can discuss and should discuss offline. Particularly, we're interested in finding out the kinds of capacity building that is necessary to take this work further. So as Adam mentioned, this is a starting point. We are creating shared assets that can be reused, but we also need to look at the different kinds of capacity that are necessary for that to actually happen. So please reach out to us with your ideas and get in touch. You'll see that we have a new website. You can send us a message there or email Adam or I and just let us know your ideas. Besides that, I'm just going to ask for half a minute to just please request some more feedback on the DataCite integration metadata layer. We have a first version out and we have COMET enrichments feeding into it, but it's early days and we need people to use it and give feedback so we can understand where it's going to evolve. So all of that is available on DataCite's website and please try it out. And with that, I think I'm going to have to end it. So thank you so much, and we'll see you soon. Cheers, everyone.
Thank you.
Thanks so much, everyone.